In this video I will show you how to solve some trigonometric inequalities. You will make use of the knowledge which you have for solving trigonometric equations, and you will also use the knowledge you have learned on the unit circle in order to solve trigonometric inequalities. To solve trigonometric inequalities, you will need to go through two steps. First of all, you have to solve the corresponding trigonometric equation, which you have already learned, and afterwards you have to interpret the solution to the inequality in question by using the unit circle and the results you have received from point number 1, that is the results which you have been given when you have solved the corresponding trigonometric equation. So how do we do that? I have chosen to include two examples. That is, the first one is sine x greater than or equal to 1 over 2, where we don't have any restrictions to x. X is equal to all real numbers. That's the first example. The second example I have chosen to include is this one you have down here, where cosine x has to be greater than or equal to negative half, or smaller than or equal to positive half. And moreover, we have a restriction to x. X has to be in between 0 and 2 pi. That's the two examples we'll look at here. Alright, so let's go into the first one. That is when sine x must be greater than or equal to 1 over 2, and we didn't have any restrictions to x. X belongs to all our real numbers. So if we remember the two steps which we had to go through, the first thing was that we had to solve the corresponding trigonometric equations. That must be, in this case, sine x equals 1 over 2. And then, if you recall on how to solve trigonometric equations with sine, then we will find x to be equal to pi divided by 6 plus p times 2 pi, or x is equal to pi minus pi divided by 6, which is 5 pi over 6 plus p times 2 pi. And p is, of course, one of our integers. So that's the first step. Now we have covered the first step. We have solved the corresponding trigonometric equation. So now we have covered the first part of solving trigonometric inequalities, which was to solve the corresponding trigonometric equations. The second part was to include the unit circle, and based on that we could find the solution to the inequality. So let's look at that. First, let's get the unit circle. Here we have it. And then we start to put in what we have already given here from the equation here. Sine x equals 1 over 2. You recall that the sine value we'll get from the y-axis. So sine x equals 1 over 2. 1 over 2 we approximately have here. So the angles which we have found up here in the equation, which is pi over 6, must be this one here, and the other one 5 pi over 6 must be this one over here. Now I have indicated the result to our equation from up here. But in this inequality it says that we're looking for values for x which sine values will be greater than or equal to 1 over 2. So it must be sine values which are greater than or equal to 1 over 2. That's the one which I've indicated here. I think we can agree on that all these values here are greater than 1 over 2. So we can see that if we're looking into angles which are greater than or equal to pi over 6, will all gives you sine values which are greater than 1 over 2. And that will happen until you reach 5 pi over 6. If you get angles greater than that, then you will certainly receive a sine value which is smaller than 1 over 2. And so you can also see over here, if you have an angle which is smaller than pi over 6, then the corresponding sine value will be smaller than 1 over 2. So we can actually see that it's all these angles here going from pi over 6, going from pi over 6 and up to 5 pi over 6, which will give me sine values greater than or equal to 1 over 2. So now we are able to conclude on the solution to the trigonometric inequality sine x greater than or equal to 1 over 2. That must be that x has to be greater than or equal to pi over 6 and smaller than or equal to 5 pi over 6. And since we don't have any restrictions to x, we can see that every time we add one journey, that is every time we add 2 pi, then we'll get back to another solution area. So we have to include pi over 6 plus p times 2 pi. X has to be greater than or equal to that. And x at the same time has to be smaller than or equal to 5 pi over 6 plus p times 2 pi. And p has to be an integer. So that's the complete solution to this inequality in this example here. Alright. Let's jump into another example here where it's a bit more complex. And this example which I've chosen here is the one where we are looking for values of x which cosine value will be in between negative half and positive half. And we moreover have a restriction to x, that is x has to be in between and equal to 0 and 2 pi. Alright, so what do? First of all, we have to solve the corresponding trigonometric equations. We have two here. We both solve cosine x equals negative half, and we have to solve cosine x equals positive half. Let's start with cosine x equals negative half. You recall from when you learned on how to solve the trigonometric equations on cosine that is equal to plus minus 2 pi over 3 plus p times 2 pi, now that we would put in the general solution to start with. And over here, if cosine x is equal to positive half, then x is equal to plus minus pi divided by 3 plus p times 2 pi. So far so good. Now we have solved the corresponding trigonometric equations, which is the first part when solving trigonometric inequalities. Second part is to include our unit circle, just as we saw in the first example here. So let's do that. Here we have it. It's almost a circle. And like we did in the first example, we will indicate our different angles here, which we have figured out from the solutions to the trigonometric equations. First of all, we could put in this one here. We can see that we're looking for when cosine x has to be in between negative half and positive half. So negative half, that must approximately be over here, and positive half, that must be here. So we could actually see that the angles which we have figured out must be from this one and this one and that one down here, and we have one more down here. So if we should label these angles, which we have just figured out the result for up here, this one must be pi over 3, and this one down here is minus pi over 3, and the positive positive angle of minus pi over 3 must be 5 pi over 3, so that must be this one here. That one over here is obviously 2 pi over 3, and that one down here is minus 2 pi over 3, and the positive value of minus 2 pi over 3 is of course 4 pi over 3. So now we're almost there, because we can see up here that we're looking for solutions for x where the cosine value is in between minus a half and a half. So the cosine value, which we can find on the x-axis, must be here, in between minus a half and a half. So actually we can see that angles which are greater than or equal to pi over 3 all gives us cosine values which are in between minus a half and a positive half until we reach 2 pi over 3. Then for angles greater than that we suddenly reach a cosine value which is outside our solution area, and that will be the case until we reach again the 4 pi over 3 down here. If we then look for angles greater than that, we again part of the solution area until we reach 5 pi over 3. Over here we will again receive angles which has cosine values outside our solution area. So we can now interpret from the unit circle that the solutions which we are looking for in this inequality must be here and here. Alright, so let's try to note it up. We see that in order for cosine values to be in between negative half and a half, then x has to be greater than or equal to pi over 3 up to 2 pi over 3, or in between 4 pi over 3 and 5 pi over 3. That's actually a solution, because we don't have to bring in periods here, because x is only defined for one journey around the unit circle from 0 to 2 pi. So if we go further than that up to 4 pi, 6 pi and so on and so forth, it's not part of our solution, it's not part of our restriction for x. So the entire solution to this inequality must be exactly what is given here. Alright, so just remember, when you have to solve trigonometric inequalities, you have to first of all solve this corresponding trigonometric equation, and then based on that solution from point number 1, you are able to interpret the solution to the inequality on the unit circle. So if you have any difficulties in solving the trigonometric equations, look into the videos which covers that theory. That was all for now. Thank you.